it was just another morning along the Pacific Northwest coast, until scientists issued a chilling warning. A mega-tsunami, possibly 1,000 feet tall, could strike cities like Seattle and Portland within minutes. The threat is real, and its causes echo an even more immediate disaster that just unfolded in Alaska's wild fjords. The Cascadia Subduction Zone, a 600-mile-deep fault stretching from British Columbia to Northern California, lies silent beneath the ocean, seemingly resting. But beneath its facade, tectonic stress is building. A new study by researchers at Virginia Tech warns that this buried power could unleash a mega-tsunami capable of racing ashore in moments, with waves soaring as high as 1,000 feet. This isn't science fiction. Imagine a colossal wave, taller than any skyscraper, sweeping through Puget Sound or the Columbia River Gorge, leaving devastation in its wake. The study stresses that the seismic quiet may be lulling us into false complacency, and that preparedness must start now. Now, shift your gaze north to the remote beauty of Tracy Arm Fjord, Alaska, where nature has already delivered a terrifying preview. On August 10, 2025, at roughly 5:30 a.m., a massive landslide crashed into the icy waters below, triggering a localized tsunami that roared through the fjord.
On Harbor Island, 3 kayaker guides, Sasha Calvi, Billy White, and Nick Heilgeist, were camping well above the high tide line, confident in their experience. But nothing prepared them for what followed. I look out of the tent and then I see a massive wave coming like inches away, Calvi recalls. In seconds, gear vanished, kayaks were swept into trees or lodged on cliffs, and chaos erupted. It was just pure chaos out of nowhere, Heilgeist says. These eyewitness accounts reveal the raw power of nature, and how little warning even trained guides receive when geological fury strikes. Scientific data confirms the wave's terrifying scale. At Sawyer Island, debris and water surged up 100 feet, 30 meters along the hillside. Further out, tidal gauges in Juneau recorded more modest wave heights of just over 1 foot, demonstrating how narrow fjords can amplify waves dramatically. Seismologists estimated the landslide involved tens to hundreds of millions of cubic meters of rock smashing into water and unleashing a devastating wave. Here's the science behind it. In narrow, confined spaces like fjords, displaced water has nowhere to go. It slams one shore and rebounds back, echoing for hours, creating resonant waves that can devastate along the coast, a phenomenon known as the bathtub effect. Even 110 kilometers away, in Juneau, tidal gauges showed abnormal fluctuations for hours after the event. What's alarming is that this event in Tracy Arm wasn't preceded by a big earthquake. Instead, several smaller tremors occurred beforehand, possibly early warnings of slope failure. If scientists can harness this, they might one day predict similar collapses before they happen. What saved lives this time was timing. No cruise ships were inside the fjord when the tsunami struck. Had they been, the consequences would likely have been catastrophic. This close call serves as an urgent reminder. Isolated tragedies offer valuable lessons in mitigation, but only if we pay attention. It's not just Alaska that's vulnerable. With glacial melting and destabilized mountains worldwide, from British Columbia to Norway, similar disasters are possible. Already, studies warn of global tsunami threats tied to climate change, geology, and glacial retreat. Back to Cascadia, that region is not immune. A major subduction quake could instantly unleash an enormous wave. Cities on the Pacific coast may find themselves with only minutes or even seconds to evacuate. Remote events like Tracy Arm may go unnoticed until it's almost too late. Smaller precursor tremors could become key signals if systems catch them early. Coastal resilience must involve timely warnings, infrastructure planning, and public drills. Studies out of the Cascadia Zone emphasize the need for urgent preparedness in urban centers.